What is up, guys? It's Science Duros here, back with another video. Today we're going to be learning about microscopes. Make sure to smash that subscribe button, smash that like button, and comment down below if you like this video.
Thanks for that wonderful introduction, Francesca. So today we're going to be talking about first electron microscopes, and then we'll talk about some of the other tools used in biology. So, electron microscopes. We don't have one here. An electron microscope is similar in some ways to the light microscopes that we've been using, but instead of the light microscopes, they use light to make the image. There's a light below, it shines through your image, goes through lenses, and you can see it. An electron microscope actually uses a beam of electrons. If you maybe remember back to junior high, electrons are tiny little, they're called subatomic particles. They're really small. And so an electron microscope can actually give you a really large magnification, really large resolution. You can see images magnified to a much greater degree than you can with a light microscope. So the main difference is that an electron microscope uses a beam of electrons to make the image, not light.
Oh, I'm sorry, I can't find them.
Did you look for it?
Oh, I'm sorry.
It's right here.
Oh, those are? Oh, I'm sorry, I didn't know.
So it uses this beam of electrons to make an image. These first started to be created in 1930, so a lot later than the light microscopes. We talked a little bit the other day about the history of microscopes. So these were developed in the 1930s, and they work a little differently because you have to put whatever you're looking at has to be in a vacuum, a chamber that has no air and no molecules. Often the material you're looking at, you have to coat it in metal. So it's a little bit more difficult to view things. You can't really look at living things in this electron microscope. But they can give magnification up to 10 million times. So that's really much larger than our other microscopes. This is like the first one. So it looks like an oven or something, an old school stove in a kitchen or something. This is from 1933. That was one of the first. Today, they just kind of look almost like a computer. And so this is the chamber where you have the vacuum and the electron beam and so forth. And the image actually is made on the computer. You kind of capture images from this. I actually have one. Whitesboro High School has one. I went to a workshop there once, and we can use it. And I don't have it in here. It used to be at Perry. I took a little picture of a butterfly wing that was kind of cool. So that's what they look like. There's two types. One is called a transmission electron microscope. The electrons go through the specimen, kind of like our compound microscope. It gives a really high magnification. The other type is more like our dissecting microscopes. It gives you a three-dimensional image. And this is an example of transmission electron microscope. This is a mitochondria from a cell. This is a scanning electron microscope image. So it gives you this kind of three-dimensional view. This is an ant. And so if you see, sometimes you see these usually they're black and white. Sometimes they're colored after the fact, artificially. But you see these kinds of enlarged images of insects and worms and things like that. Often they're made with this scanning electron microscope. The last couple tools we'll talk about are things we're actually going to come to later on in the year, but we'll mention them here. And these are ways, often in biology, we have a mixture of different molecules that we want to try to separate. And we can do that in a couple ways. One is through this process called chromatography. We'll do this at the end of the year. And chromatography basically, when you guys were in maybe 7th or 8th grade, did you ever do an activity when you put marker on paper and then soak it in water and the colors separate? You guys did? What was your teacher that you did it? Did you hear Chelsea? Oh, different. Francesca, you did it?
Yeah.
Who was your teacher?
I think it was Manly's.
Is it Canal?
No.
Machine? Manly?
No. Yeah, I think it was Manly.
Yeah. Did you guys do it? No. Oh, so maybe some teachers did it and some didn't. So basically, you take a small drop of some mixture, put it on the paper. You sort of hang the paper in a liquid, which travels up because it absorbs the liquid, and it carries the mixture of pigments with it, and they separate from each other. It looks like, I'll show you a picture in a minute. Yeah, here's what it looks like. So what they did on this is they took some ground up plant matter, formed it into a liquid, put a drop on this paper, and then they soaked it in a solvent. And as the solvent rose up the paper, the different components of the mixture separate from each other because some of them move faster, some stick to the paper more. They have various characteristics. And so you could actually see that this plant extract is made of several different pigments, and they've all separated from each other. That's called chromatography. Something that's kind of similar is done with DNA. So we'll talk a lot about DNA towards the end of our class. DNA electrophoresis, basically you take a strand of DNA, which you can get from all sorts of sources. You use a special chemical called an enzyme to chop it up into lots of tiny pieces. And then you put it in this gel and electrify it. And because of the charge of the DNA molecules, the DNA starts moving through this gel. Small pieces can move really far very easily because they squirt through the holes in this gel. Big piece of DNA, they can't go as far because it's harder for them to make their way through the gel. And eventually, you stain it and you get a pattern of these bands. Each of these bands represents some DNA. This kind of thing is used sometimes in analyzing DNA from crime scenes, for example. Like if you take, is anyone taking forensics now? You take forensics someday. DNA analysis is used if you have some DNA from a crime and you have some DNA from a potential suspect. You can do this process, and if they match up, and it tells you likely the DNA from the crime scene is the same as the DNA from this person. It can be used in testing for paternity, can be used for testing for different diseases and other things as well. And then there's also another neat tool, we won't use this, but called spectrometry, which basically you put a sample of something in the spectrometer and it can identify what elements are in that sample. Okay? And you can analyze that. So those are some of the tools that we use in science. And like I said, some of them we'll be using as the year goes along. But I just want to mention them here because we're talking about scientific tools. Any questions? All right. Thanks for watching, everybody. See you next time on Science Doodles.